Well, I want to start over and do this last one, and we get this wonderful little kit out. So if you look at number 9, I said the number 9 is a compound. So first off, let's just talk about the difference between a compound and molecule. And I can use like these notes that we did from our in-class lab. You have the matter notes as well. You're watching this video. All of these things below are molecules because they're all stuck together. I got O3, which is ozone. I got oxygen gas, O2. I got chalk, CaCO3. And I got methane, CH4. They're all molecules because they're all different sort of atoms stuck together. But 2 of these are special. And these 2 are special because they are made up of different types of elements. Because they're made up of different types, they're a special type of molecule known as a compound. Again, all of these are molecules, but these 2 are compounds because they're made up of different types of elements, which is what I wrote for number 9. Now, N2 and O2 are molecules, not compounds. These, which is O3 and O2, are only made up of one type of element, so therefore they're just going to be molecules. I repeat, all of these are molecules. These are special types of molecules known as compounds, while these are just molecules because they're only made up of one thing. And that kind of goes with number 11, as well as I just explained that. Now, a reminder as well, these things are all really hard to separate. I could separate water, but I need to do an electrolysis process. I did it in class on Friday. I'll do it for the A group here shortly. So I got to do some chemistry. I can't physically, this is ozone. I can't go up in the atmosphere and take my butter knife and chop, and separate my oxygen molecules or my oxygen atoms. That's not going to work. So these things are all very hard to separate. When I compare them to mixtures, I can physically put those together, so therefore I can physically unseparate it. Number 12 is not a question. I just like the visual. Remember, there's a digital copy as well online, so this you can see it in color. But, element X is the bigger circle, element Y is the smaller one, and mixture, and then compounds, you'll notice that they are physically stuck together, made up of different things. And then lastly, a homogeneous versus a heterogeneous mixture, and I just like to think of it as the same. A homogeneous mixture, when we mix it, it mixes evenly, and it looks the same. While a heterogeneous mixture mixes unevenly, and it doesn't look the same. All right, you ready for this? Here's my scenario. I'm going to mix my flour and sugar and butter and vanilla extract because I'm making some cookies. I probably missed some ingredients in there. I'm mixing together a whole bunch of mixtures and compounds. I produce a nice, wonderful, evenly mixed, tasty batter. That would be a homogeneous mixture, right? It looks like one thing. It's mixed very evenly. However, I'm going to start adding some nuts. I'm going to add my chocolate chips. I'm going to get real fancy. I'm going to add my M&Ms. Can y'all picture that right now? And guess what? Now I can easily tell there's different things within that mixture. So that would be a heterogeneous mixture. For examples of this, guys, look at my key. Come up with them yourself. For the first ever virtual walkthrough of a study guide, thanks for watching. I hope it helped. See ya. Double thumbs up again. All right, bye.